Okay, before I get into the meat of the talk, first of all, this was funded by a HCRI NOAA grant to Dr. Celia Smith, Kim Payton, Heather Spalding, and Dave Pence to investigate the native and invasive limu, macroalgae, and also the seagrasses. And I also want to thank these people for being my dive buddies and also helping with the diving that we did. Okay, so as Kim and Kim have already talked about the seagrasses in Hawaii, there's 3 species, 2 of what I'm going to talk about today. Halaphila hawaiiana, remember, is the shallow water one that we get off of Pico Lagoon. It does go deeper, but usually you tend to find it a little bit shallower than Halaphila decipiens, which is found all the way down to 35 meters or even more. That's the one with the worldwide tropical and subtropical distribution. Okay, so I'm not a botanist, and my first time diving on a seagrass bed, and again, my idea of seagrass were these big wavy things, and I went down there, and Kim's like, no, really, there it is. And, you know, it's kind of a little bit crestfallen, you go down there. But I said, okay, what can we do with these seagrass beds? We want to find out what invertebrates and what fish are there. And the first thing we noticed is, well, shoot, there seems to be kind of 2 different subhabitats here. That if you look right here, here's the meadow canopy, what I call, where the green leafy stuff is. And then there's everything else on the outside, the meadow perimeter, and also these blowouts where the seagrass has been ripped out. And these areas seem to form a different type of fish and invertebrate habitat. So one of the central questions that we had here is there a difference between what lives here and what lives here? So you'll hear me talk about the meadow canopy, and that's where the green leafy stuff is. And then the sand and rubble area, that's the areas where there's no vegetation, just sediment. Okay, so we had 3 research questions. First of all, we want to know what types of invertebrates and fishes were associated with these seagrass meadows. The second question we had is, does the abundance and diversity of these species differ between the sandy areas and the areas where there's the vegetative canopy? And finally, for management reasons, we wanted to know whether or not seagrass meadows were associated with any commercially or recreationally important fish species or invertebrate species. Okay, so we have 2 study sites. You've heard about both of them already. To look at Halaphila hawaiiana, we looked at the Pico Lagoon site. It's a very shallow site. It says 1/2 meter, but that was probably the maximum depth. Most of the areas where there's Halaphila hawaiiana are 1 foot or less at low tide. So it's very easy to go out there. You don't need any scuba, but you do need to stand or kneel right there, and it's actually hard to get your mask all the way underwater sometimes to look to see what types of fish or invertebrates are down there. The second site, where we looked at Halaphila decipiens, we actually had 2 sites that we concentrated on. Both of these were deeper sites, the first of which was the sea tiger. It's a wreck off the south shore, off of Waikiki. It's in about 30 to 40 meters of water. So we did need to dive on this site, and Kim talked a little bit about the methods we used to get down there. We used mixed gas decompression diving, both using rebreathers as well as standard scuba tanks. And at these depths, we could stay, what, about 45 minutes? So we had about 45 minutes for each dive to work on the bottom. There's another site off the airport. It's in about 20 meters we also worked at. And at 20 meters of depth, about 60 feet, we had up to 3 hours to work at that depth without any decompression. So we had a lot longer at this site. Okay, so we're surveying fishes and invertebrates to find out what's there. So we have a couple different levels of methods of things that we did. First of all, for large-bodied fishes and invertebrates, things like urchins and snappers and fish that you can see easily, we just simply swam around and counted them, okay, and identified them that way. We would take photographs. If we weren't sure of what a species was, we would collect it, or if it was a fish, we would spear it. Okay, so this is relatively easy to just go around and photograph and count fishes or invertebrates. Okay. Small-bodied fishes, on the other hand, these are things that are under 100 millimeters in length, tend to be a lot harder to identify or even see in a visual transect. And small-bodied species account for a large proportion of the biodiversity in fish fauna in Hawaii, so we wanted to make sure we didn't miss these. For that reason, we used clove oil anesthetic to collect these fishes. What we would do is take a 1.5 meter square plastic tarp that was weighted down and set it either over the sediment or over the meadow canopy. And underneath that tarp, we would apply about 100 milliliters of a clove oil solution which would anesthetize any fishes or invertebrates that are under there. They would come floating up, and after about 10 minutes, you could take that tarp off and pull up and collect any invertebrates or fishes and identify them back at the lab. This also was a benefit because it allowed us to estimate the density of these fishes that are down there. You have a 1.5 meter squared area, you can figure out what the density is, how abundant these fishes are per unit of area. And the use of anesthetics is not something that's normally permitted in Hawaii, so we did have to obtain permission from the Department of Land and Natural Resources. Okay, before I get on with the other methods, because there's still some more to go, I really want to make a plug for using anesthetics to collect fish and estimate diversity. This is some information we had on Avernvalia, which Kim has already talked about. It's not a seagrass, but we can see here that some of the species we've collected or observed over these Avernvalia beds. So far in our work, we've seen 29 species of fish associated with Avernvalia meadows. Of these 29 species, 11 were found only in clove oil collections. These are species that were completely missed by visual surveys and account for 40% of the diversity. So 40% of the diversity would not have been accounted for if we'd just done visual surveys. And these aren't necessarily fish that are very rare. In fact, one of these, this cardinal fish here, Apagonyctes perdex, was among the most numerous and most frequently occurring fishes within the meadow, the canopy of this macroalgae. Okay, so invertebrate stuff. This is the part that Asuko Fukunaga dealt with. So she did macroinvertebrate surveys as well as surveys for infaunal invertebrates. Infaunal invertebrates are things that are buried down in the sediment. And again, you can't survey those visually. So she would use a sampling core to collect a plug of sediment at each site. She would take 3 sediment plugs, both from in the canopy itself and then in the outside area where there's just sediment. Okay, she would fix these in formalin and then sieve out the sediment and take the organisms back to the lab to identify those to the lowest possible taxonomic category. Atsuko is in particular a polychaete expert, so she was able to go back and take these polychaetes and identify them down to species level. Okay, there's a couple different things I'll talk about. We've already talked about what the subhabitats are, the sand and the rubble on the outside of the meadow or in the blowouts, and also the canopy, where's the area where the vegetation occurs. I'll talk about fish as in percent occurrence. That is, how many stations do we do? Out of 10 stations, how many stations did a fish show up in? If we do 10 stations and a fish shows up in 6 of them, then we have a 60% occurrence. Percent relative abundance is just the number of individuals of a species recorded in a particular subhabitat divided by the total number of individuals collected over the entire study. Okay, so I'm going to go over the results first for Halophila hawaiiana. Again, that's the shallow water species off of Paiko Lagoon in Wanalua Bay. Most of the work is in a half a meter or less. This slide shows the family diversity for fishes collected at the Paiko Lagoon site. Now this is based on both visual surveys as well as clove oil stations. We did 16 of them in all, 8 in the sandy areas and 8 within the meadow canopy. We collected or observed a total of 8 fish species from 5 different fish families. So that's a very, very low diversity for this area. The family with the most diverse, the highest number of species, were the gobies, small little guys that you'll find on the sediment, and all the remaining families just had 1 species. Okay, so here are some of the fishes that we saw in our visual surveys, and some of these slides come to us from Kim Payton, who was out there for a long time taking pictures of fish that she would see in her seagrass meadows. Okay. Bathygobius cocosensis, small little sand-dwelling goby, occurs on the sediment. It's probably one of the most numerous fish out there.